Yep, and especially even for the next test, I'd also not so much focus on, say, the problem itself, but the wording and how I talk about it, because that can sometimes help more than. So since the biggest term outside is x squared, so we need x squared and then 0x. 1. Okay, yeah. So 7x cubed plus x squared plus x plus 0. Because since there's no constant term, we add in 0 and then 0x. Does that make sense?
Yeah.
So, do you want to look at that one, or do you want to try it first?
I'll try first.
Okay.
I don't have problems. When I do the other questions.
Okay. I'm going to take this. All right, before we get started, we'll look at question number 7 from last night's homework. Let's 0x. So, outside. All right, guys. X squared plus x plus 2 divided by x squared minus 1. So this is what we're dividing, so we put the term inside our x cubed plus x squared plus x plus 2. Now that one doesn't have any terms missing because we start with x cubed, so we need cubed squared x constant term. What goes on the outside, x squared minus 1, so the biggest term is x squared, so we need x squared x constant. So we're missing that x term, so we fill it in as 0x. Now the first thing we're going to do is our division, or dividing the biggest term inside, divided by the biggest term outside. Well, x cubed divided by x squared is going to be x, so that's going to be our first part of the answer. Then we take that there and multiply it by our expression outside. So we're multiplying x by our x squared plus 0x minus 1. Well, x times x squared is x cubed. X times 0x, well, it's still going to be 0, but our x times x is x squared. So realistically, that would be 0, but we're still leaving it as 0x squared, just so it holds that spot, so we know when we're combining like terms. And we put it underneath x cubed plus 0x squared minus x. And then we're going to subtract. X cubed minus x cubed is 0. X squared minus 0x squared, 1 minus 0, is just going to be 1x squared. X minus negative x, our negative makes a plus, giving us plus 2x, and we bring down our 2. Now we repeat the process, our biggest term inside divided by the biggest term outside. So we have x squared divided by x squared. Well, anything divided by itself is 1. So that turns into positive 1, and well, we're going to do 1 times x squared plus 0x minus 1. Well, that's just going to be itself. Then we will subtract x squared minus x squared is 0. 2x minus 0x is 2x. And 2 minus negative 1 is going to be positive 3. Giving us 2x plus 3 as our remainder. So we have x plus 1 plus 2x plus 3 over x squared minus 1. Even though we did add the 0x in the process of solving, we don't add that 0x back into the answer. We just remove it back out because 0x is just 0. Does that make sense? Questions on this? Here, we feel good about this here. All right. What we're doing today, is synthetic division. All these steps. One, solve for the divisor of the variable with the biggest power. So what we're dividing it by, we want to get the variable with the biggest power by itself first. Everything else on the other side. Two, we're going to set the problem up talking about the coefficients and doing that there. Three, we drop the first numbers, or we drop our numbers depending on the setup. Normally, in the ways we're going to do this, we drop the first number down below the line, multiply number inside the cubby with the number below the line, place it under the next number, add straight down. Repeat this process. Now, it sounds like a lot of steps. This seems like a lot, but when we start looking at it, I have a feeling, and if I were a betting man, I would bet that you're going to like this better than what we did yesterday. So, first step is we take what we're dividing this by. In this case, it is m minus 3, and we want to solve it for the variable with the biggest exponent, which for most of these here is just going to be solve for m, solve for the variable. We want to get it by itself. So we set it equal to 0, and I'm going to solve for m. So the first thing we want to do is add 3 to both sides. Now, if the variable with the biggest exponent has a number in front of it, before we do anything, we have to divide it out. That's one of the not as nice things with this here, but we have to divide the whole equation by it. So for this here, if it had been, say, 2m, we have to divide the entire equation by 2. Both the m minus, or the 2m minus 3, if that was the case, and that entire first expression. We have to divide the whole thing. But here, we don't have to worry about that. We just have to get m by itself. So it is 3. Okay? We're ready to set the problem up. So first thing we're going to do is we're going to make a cubby, and we're going to draw one line. Because since the degree of what we're dividing by is 1, m minus 3 is 1, we just do a cubby in one line. Now, if the degree was, say, 2, we would have 2 lines. Now, we take the number, we just solved for with m, which is positive 3, yes? We put it in the cubby. Okay? What's being divided? Our m cubed minus 13m squared plus 24m plus 18. We want to take all the coefficients, the numbers in front of the variables, and if one's missing, we're going to fill it in as 0. So the number in front of m cubed is 1. Number from in front of m squared is negative 13. Number in front of m is 24. And our constant term is 18. Now the numbers going across there should be one more than the degree. Since our degree of that is 3, we should have 4. Our m cubed, m squared, m constant. We should have 4 numbers up there. 1, negative 13, 24, 18. We do have 4. Questions on this so far? We good with this so far? Yes? Okay. Next step. We drop that first number down below the line. I draw an arrow just to remind myself we drop it down, and we have this here. I'm going to use a highlighter to signify what we're about to do, a lot of the processing steps. It's going to look very cluttered by the end. So I wouldn't draw the lines, I wouldn't draw the arrows, okay? I'm doing this so that we can see how it connects. Because the first thing we're going to do is we're going to multiply the number inside the cubby with the number below the line. So that's going to be 3 times 1, which is 3. And we're going to take that number and put it below the next number above the line. Okay? What do you got to do with this here? Our next step is to add straight down. So we want to add negative 13 plus 3, which is negative 10. And this number goes below our line. Okay? We ready for the next step? Now we're going to multiply the number inside the cubby with the number below the line. So we're going to have 3 times negative 10, which is negative 30. And then we're going to put it under the next number above the line. Questions on this so far? Question? Okay. Now, what we're going to do is what? We're going to add straight down. So the two numbers we're adding is 24 and negative 30, which is indeed negative 18. And it goes below the line. Yep. Then what are we going to do next? We're going to multiply again. We're going to say 3 times negative 18, which I believe should be negative 54. Or we take that and put it under the next one. And then lastly, we add straight down. 18 plus negative 54 is going to be negative 36. And the negative 36 goes below the line. So really we drop that first number, multiply, put it under the next one, add straight down, multiply, add, multiply, add, multiply, add. Do I get a number off? That would, yes. Yeah. Yeah. Yep. Oh, that's the wrong one. So negative 6, which would change this. Negative 6, negative 18, negative 18, and then it gives us 0. Thank you. So again, that's why I said I wouldn't draw all the arrows, because that got really messy really quick, yes? So we see the process of what we're doing. We still have one last thing we need to do to finish this up, but can we say already we like this a little better than long division? Now the last thing we need to do, because we took the variables out when we put this in, we have to put the variables back in. Now, the last number, or the last group of numbers, is going to be the remainder. And the numbers that we have contained in the remainder is always going to be one less than the degree of what we're dividing it by. Since the degree that we're dividing it, well, terms. Let's go terms, not degree. Or one less degree. So the degree that we have for what we're dividing by is 1n minus 3. So the degree for the remainder should be 0, not 0 terms, but 0. So we should just have a number. 2 terms in what we're dividing this by. So the remainder, if we have one, should have 1. If the degree was 2, we should have 2 terms, or degree 2 in the remainder. Kind of make sense? Kind of like what we had yesterday, we divided by an x squared. Our remainder can have an x and a constant. Here, we only have m, so the remainder, if there is one, is just a number. But since the remainder is 0, there is no remainder. We move over to our numbers. The first number next to the remainder is our constant, the term without a variable. The one next to it, we have a variable to the first because we increased the power by 1. The one next to it would be m squared. So outside the box, outside the remainder, constant, no variable. Variable to the first, variable to the second. If there was another number, third, fourth, we just keep increasing the power. Which is telling us that the solution here is m squared minus 10m minus 6. And if there was a remainder, we would plus whatever the remainder is over what we were dividing by originally. We wouldn't put it over the 3 here. We would put it over m minus 3 because that's what we're dividing it by. Questions on this here? We ready for the next one? So, 2 things. One, we need to solve v plus 4. Solve for v here. We could do that because solving for v, the first thing we would do is subtract 4, telling me v is -4. The numbers going across the top. We'd have 8 for v to the 5th. That's our variable with the biggest power, yes? Our v to the 4th number is 32. Our v to the 3rd power is, we don't have one, so v to the 3rd, we'd have to fill it in as 0. V squared is also 0. Now v would be 5, and our constant term would be 20. Since the degree of what's being divided is 5, we should have 6 terms. We have 8, 32, 0, 0, 5, 20. And if any of those were minused, it would be negative. Questions on this here? First step is to bring down the 8. Yes? And then we're going to multiply our -4 and 8. We get -32. And we take the -32 and put it under the next number above the line. Then we add straight down. 32 plus -32 is indeed 0. Now we repeat the process. -4 times 0 is indeed 0. Yes? Then we would add straight down. 0 plus 0 is 0. I'm not going to write the next multiplication, the next few out, because we're going to do -4 times 0, which is 0. 0 plus 0 is 0. -4 times our next 0 is 0. 5 plus 0 is 5. Now we do have a new multiplication because now we're doing -4 times 5, which is indeed -20. Goes under our next one, and we would add straight down and get 0. And most of the ones we'll do, most all the ones you'll do this with, the remainder is only going to be a single number. 2 terms what we're dividing it by, so we should only have 1 term in the remainder. And the remainder works the same way. The first number would be a constant. If there's a second number in the remainder, it would be variable to the first power. Outside our 5 would be our constant. The first 0 would be, well, we're not using x, we're using v. Then we'd have v squared, v cubed, and then v to the fourth, telling us that our answer is 8v to the fourth. These three zeros, 0v cubed, 0v squared, 0v, we're not going to use any of them because that'd just be 0. We then just have plus 5. So 8v to the fourth plus 5 is the answer. Questions on this here? Are you ready for the next one? So before we can even start this one, if you look at what we're dividing it by, we now have 3x minus 1, yes? If we have a number in front of that variable with the biggest power in what we're dividing it by, we have to get rid of it. So the first thing we have to do with this here is we're going to have to divide both of these by 3, which is fine. Because that's just going to tell us 3x divided by 3 is x. And 1 divided by 3 is going to give us 1/3. We'll leave it as a fraction because this is going to work better in fractions, and the decimal for 1/3 is 0.3 repeated. It's a repeated decimal. We'll leave it as a fraction. However, we can't just divide the second part by 3. We actually have to divide everything by 3. 3x cubed divided by 3 is x cubed. That's fine. Negative 4x squared divided by 3, well, that's going to be negative 4/3. 17 divided by 3 is 17/3. Well, at least 6 divided by 3 is 2. If we divide everything by, if we have that 3x, that number in front of the variable with the biggest power, in this case, and all the ones we'll do is going to be x or m or to the first power. If there's a number in front of it, we have to divide the entire equation by that number, by that term. Okay, I'll have to go back and fix it or figure out what went wrong. Because I have the right one, but yeah, we'll have to do it at a different time then. So we have to divide the whole thing by that number. Questions on this here? And really, that's the only change. Because everything else, we take our x minus 1/3, set it equal to 0 to find the number that goes in the cubby. For this here, we would add 1/3 to both sides. Our negative 1/3 and 1/3 would cancel. 0 plus 1/3 is positive 1/3. Across the top, we'd have 1, negative 4/3, negative 17/3, 2, we bring down the 1. Now the first thing we're going to do is multiply 1/3 and 1. And well, 1/3 times 1 is 1/3. We put it above the line under our next number, and then we're going to add negative 4/3 plus 1/3. And we do negative 4/3 plus 1/3 is negative 1. Then our next step is going to multiply negative 1 by 1/3. I know I wrote it flipped. It would be negative 1/3. And really, I can grab the calculator if I had it handy and just say times 1/3, which is indeed negative 1/3. And then we're going to add negative 17/3 plus negative 1/3 together, yes? Plus negative 17/3, because I can just hit plus negative 17/3 because A and S, the previous answer the calculator had, is our negative 1/3, yes? telling me that it is -6. Then what are we going to do? 1/3 times -6. So I can come over and say times that previous answer by 1/3, which is -2. And lastly, we're going to do 2 plus -2, which is 0. This one, just like the one before, the last number is our remainder, which is 0. The 6 is our term without a variable. -1 is our term with x. And the 1 in front of it is x squared. So our final answer is x squared minus x minus 6. Questions on this here? I feel pretty comfortable with this here. Let's see here. Let's do one last one. And then we'll move on to the second part of the lesson. The other part? Yes. So the first thing we need to do is take our x plus 1, set it equal to 0. We're solving for x. So in this case here, we just -1, telling us x is -1. Our numbers going across the top would be 3, -2, 2, -5. Then we would drop the 3. Okay. We're ready to start multiplying and adding. Yeah. -1 times 3 is -3. -2 plus -3, -5. -1 times -5 is just +5. 2 plus 5 is 7. -1 times 7 is -7. And -5 plus -7, -12. Because 5, if we take 3 of the 5, it would take us from 7 to 10, and we'd have 2 more, -12. And it is a reminder, putting the plus in between them helps to keep you remember, or just to remind yourself that we are adding. I would do that. Because this here we are adding straight down. Long division is the one where we subtract the two terms. So if putting that plus helps you remember to plus and add, do that. Now at this point here, we have to put our variables back. The -12 is our only remainder term, because again, we're dividing by two terms, so the remainder should have one less than it. So it does have one, so that -12 is the only remainder. 7 is our term without a variable. The -5 are variables to the first power, and 3 is our variable to the second. Telling us that our answer is 3x squared minus 5x plus 7 plus, because this is the first one where we actually have a remainder, a value for the remainder. Just like long division, that remainder number goes on top, and what we were dividing it by goes on bottom. Now the number on bottom is not -1.
Come to the office. Sabra, please come to the office.
It would be our x plus 1 that goes on bottom. And that's it. So we kind of understand how the remainders work. Okay. Do we need to see another example of synthetic division? Okay. We're going to skip ahead to the remainder theorem. The one before the remainder theorem, we'll come back to it. We'll do that later. Because there is a way to do this when what we're dividing it by is a degree bigger than 1. There's just one big change to it. Remainder theorem. This is going to be very helpful for this chapter. Remainder theorem states if a polynomial f of x is divided by k minus x, then the remainder r, what's left over, is equal to f of k. So the value that we plugged in, yes? So this here, it might not be necessarily in your notes. I don't think it is, but that's fine. Because this theorem just says that if we plug that value k in, when we solve for it, got it by itself, we plug it into the function, it will give us the same value as the remainder. So what does that look like for us? So what that's saying is that for this here, x equals -4. If I took -4 and plugged it in, thank you. So if we took 5 times -4 cubed minus -4 squared plus 13 times -4 plus 29. If we evaluate this for -4, and really at this point, we could do this by hand or we can do it in the calculator. I would rather let the calculator do these kind of calculations here. Because I can grab the 30xs and say 5 times -4 cubed minus -4 squared plus 13 times -4 plus 29. And we get -359. Okay. We've done that process before. Now what we learned today was synthetic division, our Cubbian line. Now luckily, they already have the variable solved for us. X equals -4. So the number that goes inside the cubby is -4. The numbers going across the top are 5, -1, 13, 29. And we bring down the 5. Now we're going to go through the process. I'm going to, -4 times 5 would be -20. We're going to add straight down. -1 plus -20 is -21. -4 times -21 is going to be +84. 13 plus 84 is going to be +97. And then lastly, -4 times 97, 8, carry the 2, 36, 38, and it's going to be -368. Plus 29. Make sure I did that right, because 97 times 4 times -4, 388. Knew something was off. -388 plus 29 is -359, yes? Well, what did we get for plugging in -4 into the equation? We got -359 also, yes? That's kind of interesting, because that's telling me that if I plug it in, I know what the remainder is going to be. If I do synthetic division, the remainder is the value of what we would get when we plug it in. Figure does it? No. But the big thing that's helpful for this here, think back when we solved in chapter 3 for graphing, or we were solving the equation. We solved it by graphing. We're trying to find the values of x that would make the function equal what? 0, yes? So according to the 0 theorem, and we'll have it, if the remainder is 0, it means that value is a solution. And it's also going to decrease the degree if we divide by 1, yes? So we have one less zero to look for. It's going to help us solve. That's why this is nice. So this here, especially once we get good with synthetic division, because I could take the calculator out and put 4 parentheses 5 close parentheses squared minus 10 parentheses 5 close parentheses minus 21. Or if we did this by synthetic division, it's already solved for, so 5 is going to go in the cubby. Across the top is 4, negative 10, negative 21, yes? 5 times 4 is 20. Negative 10 plus 20. 10. 5 times 10 is negative 21 plus 50. It is 29. So the remainder for this function, or the value for this function when x is 5 is just, no, 29. Because f of 5 will equal 29. So the solution, if we did do the division, would be 4x plus 10 plus 29 over x minus 5. But here we're just looking for that value. Questions on this here? Two for x cubed, 0 for x squared, negative 20 for x, negative 6. One of the biggest places where mistakes are going to show up is forgetting to put the terms back in. Since we're missing the x squared term, we got to put it in as 0. And if you use a calculator to do these, do it. Grab that calculator, let it do a lot of the work for you. Because 2 times 5 is 10. Then we can say plus 2. 10 plus 2 is 12. 2 times 12 is 24. 0 plus 24 is 24. 2 times 24 is 48. Negative 20 plus 48 is 28. 2 times 28 is 56. Now you're good. And negative 6 plus 56 is 50. So really f of 2 is 50. And that's it for these here. I know these, especially long division, synthetic division, I would make sure to do the assignment. I know there are ways to look it up, but again, getting the practice with it is going to be helpful. Because as we can see here, if we get good with this, we can do this way faster than we can type it in for the most part. But questions on these here? Okay. I want you to write this down here. Make sure you get 12 through 18, 25 through 28. That is the assignment for this year. 12, sorry, for this assignment. So 4, 3, 2, 12 through 18, you're doing synthetic division to solve those there. 25 through 28, use synthetic division to find the value, like we did on those last two. Okay? Now, I am going to go over the bell with this. But if you want to stick around for it and see how this works, do. But I am going to work through this. Because it is possible to divide by a second degree polynomial function, or x squared minus x minus 4. And it does change things. Because otherwise, if we don't do this setup correctly, we'd have to do long division to solve for something like this here. Okay? Because the first main steps still kind of hold true. We have to get the variable with the biggest exponent by itself. And up to this point, that's made no sense because it's just an x. So this here, we would add 4 to both sides, giving us x squared minus x is equal to 4. If you don't want to stick around for that, that's fine. But those who do, stick around. I'm going to solve this here. So we would add x also. And that's one of the big differences with this here, is that we get x plus 4. questions on this so far? So we get that x plus 4 outside. Now inside the cubby, I'm going to do two colors. We're going to take the 1 from the x and that constant term 4. Both of those coefficients go in there. Okay? Then the setup across the top, we take the coefficients. 2 for x to the 5th, 1 for x to the 4th, negative 15 for x cubed, negative 2 for x squared, 10 for x, and negative 24. And we drop the first number all the way down. The first number goes all the way to the bottom. The second number goes one less. So if we were doing a cubic that we're dividing it by, we would have 3 lines. First number would go all the way down. Second number would go down 2. Third number would go down 1. Does that make sense? Now, our multiplication still takes place, and we multiply by the bottom number. So we're going to have 1 times 2, which is 2, and we put it under the first number. So all of that first number is going to go above the second line. We're going to multiply our 4 also by that bottom 2. 4 times 2 is 8, and it goes above that top line. So all the ones with the 4 are going to go on that line. All the ones with the 1 will go on the other line. Then again, we add straight down. Here, 1 plus 2 is 3. Negative 15 plus 8 is 7. We repeat the process. 1 times 3 is 3. 4 times 3 is 12. And then we add straight down. 7 plus 3 is 10. Negative 2 plus 12 is also 10. We're going to multiply again. 1 times 10 is 10. 4 times 10 is 40. We add again. 10 and 10 is 20. 10 and 40 is 50. 1 times 20 is, well, 20. 4 times 20 is 80. We add straight down. 50 and 20 is 70. Negative 24 and 80 is going to be 56. Do I have any numbers after it? No. So what we have to do, we're done. We've done all that we can. And we bring all the numbers that we have left over that are still hanging up above that last line, bring them all down. Now the degree of what we divided by is 2, yes? So the degree of the remainder should be 1. 3 terms in what we're dividing by, so the remainder should have 2. So this time the last 2 numbers are the remainder. And our variables, because when we had outside, we put the variables back. In this case, 20 would be the term without the variable. 10 would have x, 3 would have x squared, and 2 would have x cubed, yes? Do the same thing with the remainder. The 56 would be our term without the remainder. 70 would be our term with remainder to the first power.
So it'd be 70x plus 56 over the equation.
Yes. So when we write it back out, we'd still have 2x cubed plus 3x squared plus 10x plus 20 plus 70x plus 56 over x squared minus x minus 4.
But the 56 is negative, that's 70x.
Minus 50, yeah. So if the 56 was negative, it'd be negative 70x minus 56, or if the 70 was also negative, negative 70x plus or minus 56, we would keep the sign with it. So it's not that much harder, but there is twice as much that we're doing. Most do not teach this method because there is so much going on. It's easy to get things mixed, but it is still possible to do it this way.